This is Olaf Monien on CodeRage 10, and I'm going to talk about building a multi-threaded app with System.Threading to you. And, well, this is my only slide. So we are just going into code and thinking about the way and the concepts behind System.Threading and why we would use the new components at all. First, maybe just a few comments about multi-threading in applications.
So, actually, Olaf, I want to interrupt you here, sorry.
We're just creating VCL apps for the desktop. We rarely thought about multi-threading. Some of you, of course, have, but many of us have never thought about multi-threading. Maybe they have thought about it, but never implemented it. When we had desktop applications done the Delphi VCL way, we usually had just mouse button clicks on buttons, and when a query was ready to set off, we just clicked the button, executed the query, and that query might have taken a long while or a shorter while to execute. In that time, the user basically saw a non-reactive user interface. We basically trained our Windows users to ignore the fact that the application became unresponsive, and we trained them to, well, go for a cup of coffee if they were printing a longer report or just running a longer query. Now, where we saw a quite significant shift to mobile devices, the situation has changed a bit. With mobile devices, the user is basically asking for immediate response. If you present the user a mobile application where the button hit just takes a while, like even as less as 2 seconds to execute, where the application becomes unresponsive, your users usually become impatient. They are just used to responsive mobile applications. Everybody on an iPhone or Android just, well, if you as a user of such a mobile device hit a button, you just expect it to respond in some way immediately. So if it does not, well, you probably know it, you might kick the application from the device. Even if you or your user doesn't do that, the operating system might step in and kick the application because the operating system might think the application hung or installed in some way, and it might be consuming just battery, and so the operating system might just kill the application. All right, so this is the reason why we actually think about more multi-threading in our applications, and not just for mobile applications, it's also for desktop applications. Even in desktop applications, we can benefit from more multi-threaded execution of code that executes in the background, that is. Code that executes in the background makes your application just behave and look much more snappy. So what we're going to do today is to look at an application that I already showed off at my other session, which was about push notifications and mobile devices. So this is the same demo, and we are going to look into the places where multi-threading might help the application to become just more responsive. So maybe just let's start up the application, and for the matter of demo, it really doesn't matter to run it on the mobile devices. So we will just focus on Windows 32 platform, but the same thing would happen on devices as well. All right, so maybe just let's start the application and see what happens. Okay, so the application compiles, and the initial screen comes up in white. A white screen means, well, something is happening in the background, and here we go. After a couple of seconds, the screen turns on and shows all the actual user interface elements. So this application is a chat application. It's a walkie-talkie, how I call that. The walkie-talkie application basically lets you send some messages from this edit here. So hello world, for example, and it sends it into the system. And you see, well, broadcast sent, hello world. It doesn't really show anything in this Windows application, because Windows applications by now cannot yet receive push notifications. So the push notification would show up on a mobile device, but not in this Windows application. To actually see that something happens and to make the application more, well, feature-filled and more convenient for the user, we are storing all the messages, like the hello world message we just sent, into a database. The database is what we see here. So the last few messages are shown to us from the database. So if I hit the refresh button, it basically pulls the database. It takes a while, and it would come back with hello world at the top, which is what we expected. All right, so the database in here is not really a standard database like a database driven by FireDAC and SQLite somewhere. It's basically hosted on a parse system. Parse is a backend as a service provider, and we are using its push notification services and its storage service. So parse, just to let you know what we are talking about here, parse would be this. So parse.com, like in the URL up here, is one of the multiple backend as a service providers, and one of the features is push notifications. So we see all the push notifications that we just sent to the system. So this is the hello world we just sent. It's well, I'm in Germany. It's already late afternoon, so it's the message we just sent. And another feature is somewhere in the core, and in the core we can store objects. In our case, we only have chat messages, and you see here we are storing everything we send and adding a couple of information to it. So channel and send, date send, stuff like that. All right, this is parse, and we are talking to it through a REST interface. So the REST interface is, well, not implemented by myself natively. There are actually components for that in Delphi, since Delphi 6, XE6 or XE7. And in the data module main, we just see the parse provider and components for push events. And what I'm using here is the backend storage. All right. So let's have a look again at the application to understand what's happening. So I start up the application, white screen comes up, something in the background happens. It's basically the REST requests going to the server, which may take a while, depending on your network situation. Remember, if you're on a mobile device, you might even be in Edge or even worse in GPRS conditions, which means, well, byte by byte transmission, which may take quite a while for several hundred of kilobytes to transfer here. So look again at the refresh button. The refresh button also blocks the UI. It keeps, it stays blue, and after a while it comes back. Once again, I can't hit anywhere, so the user interface is blocked. This is something we really don't want to do. Okay, let's have a look at the code we are using here. This is just something which is not important here. And now go into the refresh. And what you can see is here the refresh button click basically calls a function or procedure refresh chat history. All right, let's see what this does. So in this method, refresh chat history, we are pulling a list of chat messages, which is here. LChat history is basically an object list of tchat message. And in the data module, there's obviously a method that we can call to return all the chat history items. Well, if an error happens, we are displaying a status saying, well, loading chat history has failed. And once we're done, once we got the chat history, we process it, well, clear out the memos and fill out the memos with the actual chat history items. All right, so the actual delay, the blocking call is this one. So this data module main get chat history is basically executing the query, is sending a request to the server. So let's have a look in here just to understand what it does in a brief way. So this is the data module get chat history. We are creating, well, a local variable to hold the result of the actual query, which is of type tchat message. And in here, just make the window a little larger, we see this is the actual request, or the actual method that would trigger the request, a REST request to the server, to the parse server. So what we do is here we go to the backend storage, call the storage, query for objects. We are asking for or looking for tchat message items. This is how the collection, or well, in terms of relational database, is called on the parse side, and we want to execute this query. Order the items by date sent in the descendant way, so this is the -4, and limit it to 8 items. Okay, so this is the actual call that might take a while. It's a blocking call. It's a blocking call to a REST API on the other side on parse. It goes through HTTP, and it really just blocks. So to have a more interesting demo, I actually inserted a sleep 5000 to make it more, well, delaying. I'm on a fast internet connection, so the delay is not as is not as visible as it could be on a slow network connection. So this is just for the purpose of the demo here. Okay, let's go back to here. So what we have to do is to make this line of code somehow run in the background thread, because this is the line of code that produces the delay, that blocks the main thread. Everything that updates the user interface has to run in the main thread, and every interaction from the user, which means clicking on a button, like clicking here, this is also all done in the main thread. So if we are looking at events like on button click, which, well, basically just calls refresh chat history, we are in the main thread. And if we execute stuff here, it blocks the main thread. Okay, so to not block the main thread, we would have to create, in earlier days, we would have to create a tthread descendant class. A thread class that has code in its execute method that would basically execute this data module main get chat history call. This is something where in former times, most of the developers just said, well, I'm not capable of doing that, or it just takes too much time to do that for now. So the user will be just fine if there is a delay and if the user interface will just stall. So when we realized, well, it's not so good, we probably called somebody who might be capable of doing that. That's this mysterious user, Jim, in our company, who is aware of doing thread classes, and we would have to talk to him and tell him, well, I have some call here, get chat history, and please make a T thread class descendant for me and call it somehow and return the value in some way. All right, so this is the reason why it basically doesn't appear in desktop applications that we would use a lot of background threads. Okay, to make things more easy, Embarcadero came up with a library called System.Threading. So we are using that library, and this is System.Threading. So System.Threading is a library that contains several new classes for executing code in the background in worker threads, that is. Okay, I'm using that library in my code, and let's see what we can do with it. So the first thing I did is create a new refresh chat history method. I call it refresh chat history future. Because I heard, well, there is a feature in that new library that is called future. So like you see here is System.Threading TTasks is the main class, and there is a method called future. And these futures are somehow executing code in background threads. So this is technically what I'm looking for. So I thought it might be a good idea to do that. So what we have to do is to call a future is to make it a generic call. We have to tell it what result type we are expecting, which is an object list of tchat messages. Okay, so and we pass in a function that returns an object list of tchat messages. That's what we're looking for. And in the body of that function, we run all the code that takes a while. Well, in our case, it's just data module main get chat history. Well, around this, we just put our exception handler like before and display something if something fails. So only this line of code here is going to be executed in a background thread. So this is a background thread now. Okay, so how do we actually, well, run this? As you can see, there is a variable that I assign the result of this future to. And this variable is basically the result type we are looking for, which is tObjectList tchat message. That's fine. And we have to put it into some sort of an interface wrapper, which is called iFuture. So this is now a future. It's not a regular variable, it's a future interface reference. Okay, so we just continue working in here, and we go to a for loop, and here we are back in our main thread, of course, actually already here. So we are in the main thread. We can anything we want to do in the main thread now by updating the user interface. So here we are using LChat History the first time. And well, it's some sort of future, so it does have a special property, which is called value. The value is now what we are actually looking for. And the value has an object list of tchat messages in it. That's the actual return or result of the function in here. And the trick, the feature of a future is that it will just run this. The code from up here will just run through. No matter how long this code takes, this will just run in some background thread. We won't notice this in the main thread from where we are calling this. So we get to this line almost immediately. And this line, this value call, will now wait until, well, our background thread has returned. Okay, good. So, well, once we have the chat history, we can just process as previously. Okay, sounds good. So let's try that. Just save that and run it. Watch the screen. Oh, again, a white screen, which means something is blocking. It's blocking the user interface. And let's see, just run the refresh, blue button. I can't click anywhere. So, well, this is somehow not working the way I thought, so, or you thought, which means, well, we actually have background thread, but it's useless in our case. It doesn't solve the problem. We really have a background thread here. We can just prove that by looking at the thread debug window. So we see thread status here, and just let's run this again to see that there is really a background thread working. So we're just hitting the refresh button. It's easier to watch. Thread status. Make the window a little larger. A couple of threads are in FireMonkey already, so let's hit the refresh button. Okay, for some reason we don't see anything here, which is always the problem when you do live coding. It should actually show a named thread here. For some reason, I can't show it right now, but what you can see is when we go back in here, and we should actually see that there is a thread start at this point down here. So, and now it returns. So it's really a thread starting, a new thread starting here. Okay. But it doesn't solve the problem because we have a background thread, but because it waits, it blocks the main thread by waiting on the background thread to complete, it really doesn't help here. Only if we had multiple jobs or tasks that need to be executed side by side instead of one after each other, we could basically use, or it would make sense to use a future, because in that case we could just connect all those futures and, well, wait for the longest running to return. But it's not helpful in our case, so we need something else. Okay, let's have a look what we can do. We go back into our methods, and we have refresh chat history task. Okay, let's have a look how this works. Okay, for a moment, step back a little bit, and let's analyze what we got here. So this is our core code we have seen previously. It's basically get chat history. What I've done here is ignore the refreshing thing. I'm going to explain that in a minute. What I've done is I added TTask run. I handed over an anonymous method, which is this. Well, I need a local variable. That's not a problem. And so I just added those lines in front of the lines I already have. This is easy. So we are calling TTask run. This is a static method which creates a thread, or actually uses a thread, and makes the code run, which we turn in as an anonymous method. So this code is going to run in the background thread now. Okay, good. So this will run in the background thread like before in the future, but this is a different thing now. So here we display a status when something happens, when for example, the network connection broke in the middle, your mobile device is walking into the woods, and you just don't have internet anymore. So, but this display status is changing the user interface. It shows something. It's basically updating a label in our case. And I told you, when we are changing anything in our user interface, we really need to make sure that this code only runs from the main thread. But if we look at the code here, I told you that this will run in the background thread. We are not allowed and should really not try to update user interface from the background thread. This is the reason why I inserted something else, which is tthread q. Just put in nil, that's just fine. And turn in an anonymous method again. So you basically just have to put in these 3 lines of code and this final line of code. So you can go through your serial code and add in some lines of additional code for synchronizing the code that needs executed in the main thread by using tthread.q. Some of you might now say, okay, tthread.q, I've not heard about that one yet, but I know about tthread synchronize. This is very similar. It does the same thing. It synchronizes the code in here between the begin and the end to run in the main thread. This is exactly what we want. The difference to Q is that synchronize will wait. It will wait until its code, which it's supposed to synchronize to the main thread, is actually executed by the main thread. This is something I don't care here in my case. If I excuse me, if I want to display a status, I don't care if it happens now or maybe a second or two later. So I just put it in the queue, and this queue is, well, what a queue is. It adds code to the queue to be executed with the main thread. I recommend using the queue unless you are really sure that you really want to wait for the result to return, for the synchronized event to return. By using queue, your system becomes less fragile in terms of more responsive and less, less behaving bad in terms of running into deadlocks. If you block your thread, which waits for this to return, it might depend on other things. If you have multiple threads, multiple TTasks running somewhere, and we're waiting for other threads, other TTasks to return, you might easily run into a deadlock. So only use synchronize if you really know what you're doing, and if you're really interested to wait on in this case. So we're using queue, and it will just be executed at some later point in time. Okay, so we got our chat history up here. No exception happened. And we come to the code which we had previously. We are updating the user interface with the chat messages that we received from parse. Okay, so parse returned the chat messages, and we are updating user interface. Updating user interface again. Just take those 4 or 5 lines of code and put them on top of your code that talks to your user interface, and, well, close it with an end like this. So this makes this code again running in the main thread, which is allowed to update the user interface. The next thing is the refreshing thing. What does this do? By running, or maybe just have a look at the code now, or the application, how it works. So we update this one here to use the task method, and we have the show feature as well. So let's do this here too. So this is also using the task now. Just ignore this start push services. This is something I explained in the other session. Okay, just let's run this. So it immediately comes up. This is exactly what we want. And after a while, I'm just not doing anything. The last 8 items come back from parse. This is exactly what we wanted. We start the application, we trigger a background thread asking parse to give us the chat history items, and when it's ready, it will be inserted into our user interface. This is how it's supposed to work. Now, let's have a look at the button. So I can hit the button and it will execute in the background. We won't see much because it will just update, so I can just, hello again, send this. This will store the hello again to parse. We don't notice anything here because we don't receive push notifications in Windows applications. And once I hit here, you see I can move around. So the user interface is responsive. And after a while, it comes back and it shows us this is something I didn't expect to work like this. This is my fault. And after a while, it comes back with all the messages from parse. So what happens if I hit multiple times? I'm now hitting the button. So I could easily start up multiple background threads. So this is the reason why you have to think about how to realize that you're done. I used a very simple approach here. When I hit the button, I don't expect the user to hit it again until the result of the button returned. When we programmed in a serial way, in the traditional way, in the main thread, we didn't have to care about this, because when we look at the refresh click event. If we click the button, the code will actually execute, and it will not return until this method has completed. So even if you hit multiple times, it will be executed one after the other. It will not execute it while the first click is still computing. But now with a background thread executing all the stuff, we could easily click and have the code execute more than once at the same time. This is something we want to prevent from happening. So let's have a look at this one. So remember, this is in the main thread. So it's safe to look at the variable. It's a form variable f refreshing. If we are not in the refresh, we can safely assume that we can now enter the code to refresh. This line of code still executes in the main thread. So the first thing is switch f refreshing to true. It's in the main thread, which means there is no synchronization issue here. So the main thread just executes linearly. And then we start off the background task or background thread, and we go to the exception handler here. If something happens while requesting parse, we have to reset refreshing. We are basically going out of we are leaving the refresh chat history task function. And because this call is now executing in the main thread again because of our thread.q call, we are safe to just reset f refreshing to false. Nobody else can do that right now. We are strictly changing f refreshing from the main thread only. And then at the end, when everything is done here, after basically updating the user interface with all the processed chat history items, we are setting f refreshing to false again. And remember, even here, we are in the main thread because of the 3-thread queue call. This is basically our synchronization tool to make sure that we are accessing a single variable only from one thread and not run in synchronization issues. Okay, so this is the core technology you need to know about to make your applications multi-threaded. And my idea is that by using TTasks, it's much more easy to make your applications multi-threaded because you don't have to think about a T-thread descendant class, which would be in a different unit or at least somewhere else in your code. You can just take your linear code and make it multi-threaded. You always have to think about the point where you're accessing the user interface and, of course, objects that might be used from different T-task runs. So there is, in my opinion, no reason anymore to not make your application multi-threaded, because in these situations, it's really easy just by adding lines of code on top of your existing code, like this. This is our existing code below the blue marked block. And just close that with an end call down here, and we know this code will just execute in the background thread. So to summarize, well, use TTasks run to make your applications multi-threaded. And that's it for today. Thank you very much. And I guess it's for Jim to take over and to look at the questions that might popped up.
Okay, so apparently there's a bit of an echo if I'm unmuted. So if the echo starts acting up, I'll have to mute my transmission on this side. In which use case would I ever use tfuture over ttask?
My idea of futures is if you have multiple jobs to be run and you need to add, basically concatenate results of every single future into one main result. Then you could use that. It would still block the main thread, but you could wait or put the waiting for the result of those futures into a TTask again. So it really depends what you're going to do. My use case for futures would basically be using them in a separate thread again, in some main background thread, and use the futures to easily wait for the results of them. That's probably where I see their purpose.
Yeah, the other place I see futures being useful is when you are going to do something in your main thread that's going to take a while, or maybe when the form comes up, when you want to have something calculated from when the user presses a button, that's going to happen later. So you can do that in the future, and then when the user presses the button, then you have the value ready. So yeah, it's a little different.
Exactly. You have to think about them. They are somehow a thing that executes in the background, and if you have to do other things first, they might be useful.
Is it possible to make a queue of?
Let's see.
Is it possible to make a queue of reset chat history task? So if we need to execute a few times, the refresh chat history task does so. We need to embed that using a task, a future, a queue, or how?
Well, one thing I forgot to mention is that everything you create in the background by using TTask is basically run off a pool of threads. So it won't create hundreds of threads if you're calling tthread run hundreds of times. It will calculate depending on your machine, on how many cores you have, and some other parameters, how many threads would be in that thread pool. So that's the first thing we need to know. And of course, you can create some sort of a queue of TTasks running. There's actually something called an array, and you can wait for all of the TTasks to complete in one array. This is maybe something the user is asking for.
Okay. In refresh history task, what is the live time of the local variable local chat history? I'm not hearing you if you're talking.
I forgot to turn on my microphone. It's probably LChat history you're talking about. And the lifetime of LChat history is this variable is inside an anonymous method. So the chat history down here is filled up here, and we are using that one later down in the same procedure. So by looking at this green line of code here, we're basically running down here, and we are using LChat history here. And once we go out of this very last line of this anonymous method, it is basically out of scope. So LChat history is declared locally. It's declared locally to a anonymous method, and its scope is that anonymous method.
Is TTask, does it have the same efficiency as a dedicated tthread class, or what's the difference?
The efficiency of those TTasks is, of course, very close to tthread. There is an overhead because the thread pool which is around them, it performs calculations. It performs calculations like how many or how much CPU time are we using right now. And there is basically an indicator that yields, I think it's at 90% of CPU time. If we are going beyond 90%, it will basically slow down TTask threads just to make sure that the main thread still gets computing power. So there is some management around them, which of course pulls a little bit of computing performance. And there is this management, piece of code that looks for, the main CPU to not overrun.
Where can they get the demo or the source code for your demo?
Yes, of course. The code will be uploaded to the CodeRage portal, and it will be available for download.
Okay, so I'll post a link for where you can download those later on. We have a page set up where we'll put all those up. Do you recommend pushing references to dynamic arrays onto the tthread queue? I'm thinking anything that deletes elements in a dynamic array is not thread safe.
Okay, anything which is not thread safe must be handled very carefully. In my case, I have this object list here, and it's strictly local to this single task here. So if you're pushing in some way something into tasks, make sure you're using either thread safe classes or use, all the known thread synchronization objects like tmonitor or tCritical section. So if you're accessing anything which might be accessed from more than one thread at a time, use tmonitor or tCritical section.
Or if they put it into the tthread.queue onto the main thread, that would work as well, right? Or not?
Exactly. That's what I'm doing with the refreshing here. It's strictly handled in the main thread as only, and that's the reason why we can just do it like this here. So the main thread is one way to synchronize things, of course. If you push it to the main thread, it will just work over there. That's fine.
Okay. Do the iChat history, is it self-destroyed or is it needed to be destroyed at the end of the refresh?
My use case here is basically a mobile application. So in mobile applications, we have Arc, which means all the objects will just be freed automatically if they go out of scope. So this one here, which is created deep down here in this call, will just be destroyed once it goes out of scope. Remember, we are in Arc, and I use Windows here just for test purposes. Of course, in Windows, we would have a memory leak, because under Windows, we don't have Arc, automatic reference counting.
Okay. I'd want to use a T-parallel for inserting records into a database from a list or something. Where should I create the database connection? Just before the T-parallel for, or where?
Technically, T database connections are not thread safe. You need at least one transaction for every thread, because the transactions cannot be shared between two threads. That's my understanding. And so you probably can share a connection, but assign separate transactions inside the for loop. That will be one thing. Or if you don't trust us, just create one connection per thread. So do it inside the for loop. But I think transactions should be just fine.
Is there a limit to the number of TTask run you can use?
I didn't hear it completely, but I guess the question is if there is a limit of TTask run calls you can do after each other. There is no limit. You can call it 100 times, 1,000 times, and it will go into some sort of a queue. It will create only as much threads as the thread pool will allow to do it. So if you have 1,000 calls to TTask run, the first dozen will execute depending on the course you have, and then they will put into the threads one after each other once threads get available.
What method for simple parameter exchange inside of the TTask would you prefer? T-critical section, T-interlocked, T-monitor, and why?
It depends. T-interlocked, to start with that one, is very easy for just simple variables, or simple values like integers, whatever. So T-interlocked is for those single variables. T-critical section is the classic way of synchronization. I still use them a lot. I started using T-monitor more and more. They are just a little bit easier. You don't need to create them explicitly by inserting critical sections in the class or the form, wherever you are using them. You can use any object which already exists as a T-monitor object. So if, in this case, we could just use the main form as a object for T-monitor, which simplifies the application or the coding, because we wouldn't have to think about when to create the critical section and when to release it again. It might still be a performance issue. My not complete tests show that T-critical sections are a little bit faster than a T-monitor, probably by nature, because T-monitors have to do some extra work to attach to the actual objects. But it's very, very marginal.
How about DataSnap connections from a client to a server? Are they thread safe?
Okay, DataSnap connections from a client, that's probably a question around, well, how do they perform? Do I need to put them into a background thread, stuff like that? Technically, yes, DataSnap connections are running in or blocking the main thread if I call them from the main thread. So I certainly have to think about putting them in some TTask environment. It's still the same, or mostly the same thing we saw here. I'm talking to a REST API to parse. And if you're using DataSnap and use, for example, the REST functionality inside TDataSnap, it's basically the same. So there is a method being called, and it's going through a REST interface through HTTP to the server, and the server will send a result, and it will be processed, and that might take a time. So yes, if you have a mobile application, especially a mobile application that queries a server for quite some values, really put them into a background task. Yes, that's definitely what you should do.
How is it guaranteed that LChat History is valid in the queued anonymous method? In my opinion, the tthread queue is a shoot and forget call, so the task can end before the queue calls are processed.
Oh, okay. The tthread queue, it's probably about this here. So we are accessing LChat history down here in the thread queue. So the first idea might be, okay, this runs, it goes off, it takes a while, but the actual code here already returned to, well, and finalized. So what I said previously is the lifetime of this guy here ends when we go out of the anonymous method in TTasks run. But the thing is, by adding this anonymous method, this queue anonymous method, we are creating a new capture. And this new capture will lead to the situation that this LChat history down here doesn't go out of scope. It goes out of scope when this queue call has executed, has finished executing. So we are, encapsulating one anonymous method in one other, which causes to create captures that go over multiple levels.
Okay. For or on tparallel4 and DB connections, would it be possible to use a connection pool that was previously created from the multi-thread? And how would the parallel for loop would have or behave when there is no connection in the pool available anymore? Could I wait in the parallel iteration that is experiencing the is unable to pull the connection from the pool?
Okay, so it's basically around if the pool has no more available connections, and if I'm inside a parallel for loop, and of course in each of those loop events, I can wait for a connection to come available. It will just make this single call or this single iteration of the loop. It will make it last longer. It will run longer, and other iterations might be just running faster because they don't have to wait. Yes, you can and should wait for connections to become available. Of course, you might check your code that if you're making things parallel by using the parallel for loop, you should probably think about the parameters, the number of threads that you have in your pool, and the number of connections that you would have in your database connection pool. I think there should be some sort of match. You should have at least as many connections in the pool as you have threads in the thread pool running your parallel for loop, to avoid the situation that you could execute code in the background, but you're delaying it because of the lack of available connections.
That seems like really good advice. In mobile development, are the native APIs thread safe? For example, may I run into a thread problems when running their native API calls, for example, Bluetooth, Wi-Fi, intents, etc.?
Native API calls like Bluetooth. Okay, so we're talking about, for example, the T-Bluetooth Manager class. T-Bluetooth Manager uses background threads by itself. So if it's discovering new Bluetooth devices, it will generate events, and in that event, it will return those devices it found in the calling thread context. So if you take a T-Bluetooth Manager class or instance, the default instance, and access it from multiple TTask run-driven threads, it probably will cause issues because it still will run background threads to look for new Bluetooth devices, but it will certainly not take care of the situation that you call it actually from multiple different threads. So I would recommend applying the standard procedures to synchronize calls to it, or give every task its own Bluetooth manager, but this won't work because this is a singleton. So that's probably the question where the actual reason of the question. The Bluetooth manager is a singleton, so you would have to synchronize access to it. And by nature, native APIs are not thread safe. No.
If I have a DataSnap server using FireDeck to query or update an Oracle database, and the DataSnap server can be accessed by many computers at the same time, does the code in the DataSnap server take care of the threading, or is it my responsibility to do these calls safely?
In this case, the server takes care of threading. So every request would basically run in its own thread without any additional interaction or coding from the developer.
But on the client application, you would still need to not share connections between threads, it sounds like, or can you?
Yeah. No, on the client side, standard procedures apply. So you have to take care of, well, if you run multiple queries against the same server, you should not share the connection.
All right, I think that's it for questions, and we're about out of time. Thank you so much, Olaf, for this presentation.
Sure, you're welcome.